All right, so lesson 4.1, the vertex form of a quadratic function. Up until now, we really haven't talked too much about vertex form. I know in the unit 1 we did, but we will really expand upon it, and in this unit, we're going to learn how to get into vertex form. Right. So this first lesson might be a little bit of a review, especially the first couple of examples here. But let's get underway. So recall being review. A quadratic relation in vertex form, y equals a x minus h squared plus k undergoes the following transformations if the values of a, h, and k are changed. The vertex of a parabola, and where is the vertex of a parabola? It's always at h and your k value. And the axis of symmetry is x equals h. So if you have the vertex, you have your axis of symmetry. The function has blank value of blank when a is less than 0. So if a is less than 0, meaning a is negative, the graph opens, I'm going to fill this blank in first, opens down. So if it's opening down, the function has a max value then, and that max value is at k. The next sentence, the function has blank value of blank when a is greater than 0. So meaning this is positive because the graph opens up. So meaning that if it was an opening up, this would be a minimum value of k. Okay? So when we want to combine many transformations at once, we can use the mapping rule for a, h, k to translate the parabola of y equals x squared. So recall, the mapping rule is you take your x values and you add the h to them. You take your y values and you multiply them by a and you add your k values. And that's it. And so the a and the k affect the y's and the h affects the x values. So in this first example, let's find our h, a, and k, talk about how they impact a graph, like state the transformations, and then let's write the mapping rule. So right here, again, this is our a value. So read the graph left to right. So talk about that a value first. Well, in this case, we have a negative, so there's going to be a reflection over the x-axis. And then it is 0.5, so it's a value that is between 0 and 1. So there is going to be a vertical compression by factor. Sorry, I almost forgot the word factor. By a factor of 0.5 because it's being multiplied. So you say factor. And then you can see that you have this h value here. So talk about that. That means there is a horizontal being the x-axis, horizontal shift right. And I say right because it is negative, so you go the opposite direction. Shift right by 4 units. And then the last one, it's a vertical shift down by 3 units. Okay, so we've stated the transformations. Now just create your mapping rule. And again, you have your x's and you have your y values. Well, your x's, in this case, they're moving to the right by 4 units, so plus 4. Your y's are being multiplied. I'll just give myself some more room here. Their y's are being multiplied by negative 0.5. So it's negative 0.5 multiplied by y, and then take away 3. So let me write that a little more cleanly. So x plus 4 minus 0.5 y minus 3. My eraser doesn't want to work. Minus 3. Okay. So let's do the same thing for example B. Well, in this case, we see that we have an a value of 2. And actually another way to look at this is y equals 2x minus 0 squared minus 6, right? So x take away 0 is nothing. You don't change anything. So that's why there is no bracket here. But technically this is still kind of in standard form. So you have an h value of 0, meaning that there is no horizontal component or translation or transformation. So we have an a value of 2, not negative, positive in this case, so there's no reflection. So it's just a vertical stretch by a factor of 2. And then you only have that minus 6 on the back, so it's just a vertical shift down by 6 units. Okay. Once again, state your mapping rule. So we must have a lot more room this time. So you have your x values. Actually, I'll just do it. We have our x values. And then because there's no h value, just the x values don't change. And then we have our a value, which is 2. That's being multiplied by your y. And then you take away your k value. And there's your mapping rule. Okay. So fill in the following table. So example 2. The only really new thing here is this column right here. And so I'll spend some time going through that column. But let's start with the first part. State the vertex. Well, the vertex is at your h and your k. So because I see -1 there, it's actually +1, 2. Well, your axis of symmetry is always at x equals h. So this is x equals 1. Your opening up or down is talking about the sign of your a. So in this case, a is negative. So that means we are going to be opening down. And then your range, all right, figure out, is it a max or a min? So, and you talk about your y value, so it's y's belong to real number, but do you have a restriction? And in a parabola or a quadratic, we always have a restriction on our y. So in this case, because we're opening down, we have a maximum, right? So that means y values will always have to be less than or equal to whatever that maximum is. And that's at your k value here. So that would be less than or equal to 2. So y belong to real number, but y's have to be less than or equal to 2. Okay. The new column. Number of zeros. So remember, what I'm asking you for here, let's just get a visual. I'm saying, does this quadratic, this y equals -x minus 1 squared plus 2, the equation that we're dealing with, does it have 2 zeros where it intercepts the x-axis twice? Or does it have 1 0 like this? Or does it have no zeros like that? Actually, I made my blue and my green wrong. Does it have, or my purple and blue green, does it have no zeros like that? So there is a formula that you can use. All right. So the number of zeros, remember from the previous unit, how do you calculate your number of zeros? Or how do you calculate zeros in general? Well, it's when the y's are equal to 0. All of these points right here, all of these points have a y coordinate of 0. That's why we call them 0. Actually, this one has no 0. So you take your formula, the -1, the -x minus 1 squared plus 2, and you set it equal to 0. And we are solving for this x value. So before I give you the formula, let's solve and let's figure out let's figure out what our zeros are. So we're solving this. We need to get rid of this 2 first, SAMDEB. So bring the 2 over. So that becomes minus 2 equals negative x minus 1 squared. The next step is to get rid of this negative right here. So divide it by negative 1 on both sides. So that gets rid of this. And then negative 2 divided by negative 1 is 2. X minus 1 squared. The next step is to get rid of that squared. So you take the square root of both sides. And now this is the key part, okay? When you take the square root of something, so right now we have the square root of 2. And that is equal to, well, taking the square root gets rid of this exponent, so you just have x minus 1 on the other side. When you take the square root of something, remember, there are 2 possible values. You'll get a positive answer or a negative answer. Because, for example, if I took the square root of 9, again, minus 3 gives you that answer. So your answer could be minus 3. That is a possible value because minus 3 times squared is the same thing, just as the root of 9 can equal 3. So understand that there's 2 possible answers of root. Well, then your solution is either going to be, if we bring this 1 over, so you'll either have the positive version of the root, so the positive version of root 2 plus that 1, that can give you one of your solutions. So that is one possible solution. Or it could be the negative of the root plus 1, and that could be your other solution. Okay, so you have 2. You have 1 and 2 solutions, 2 roots or 2 zeros. So I'll give you the formula after we do the second one because I want you to be able to draw a conclusion, okay? So in this case, we had 2 zeros. Well, let's fill in the chart for the second one. So y equals 2x minus 4 plus 3. So our vertex, 4, 3. Axis of symmetry is at your h value, so our h is 4. So x equals 4. We have a positive a value, so it's opening up. And because it would be opening up, that means we're going to have a minimum. So then when you write your range, y's will always have to be bigger or equal to your minimum value. And that minimum value is at 3 because 3 is your k value. Okay, so back to this, number of zeros. Well, same approach, write your equation. So and set it equal to 0. So 0 equals 2, 2x minus 4 squared plus 3. X minus 4 squared plus 3. So we are going to isolate for the x in the same fashion, okay? So bring this minus 3 over, this positive 3 over first. Bringing it over becomes minus 3 equals 2. X minus 4 squared. We'll now get rid of this multiplication of a 2 in front. So these cancel, and you're left with minus 3 over 2 is x minus 4 squared. Okay, well, you would follow the same approach. Then you'd say, okay, I'm going to take the square root of both sides because I got to get rid of this squared up here. So then you would get, and I say this very lightly, you would get the root of minus 3 over 2 equals x minus 4. But you cannot evaluate this. That's because there is a negative. You can't take the square root of a negative number. So because there is no way to evaluate this, or there is another way of saying it, no solution, and remember solution and zeros are synonymous with each other because there's no solution, there are no zeros. So meaning you have a scenario that would be like that third one I showed you. or is like this, okay? You'll never hit the x-axis. Well, so let's make some sort of conclusion here, okay? Because there's a faster way, instead of you solving every time here. Well, if we look at the first example, we were able to solve it because there was a positive value under the root. If we look at the second one, we couldn't solve it because there was a negative under the root. So we can't have a negative under the root. So what causes a negative under the root? Well, if we have our first scenario where we have no zeros, that means, actually, let me just write the formula up top. If we have your a, your x, minus h squared plus k, okay? So when we are solving for this, when we're solving for the x, when we're solving this, we're solving for the x. So the first step is to always bring the k over, okay? Well, when you bring the k over, right, so then the first step would make this k equals a x minus h squared. And then the second step was always bringing the a over. So you divide both sides by a. So you get k over a equals x minus h squared. Okay, and that will always be the case. Well, now, notice, the next step would be to take the square root, as we did. So if k divided by a turns out to be a negative, we have a problem. All right, so what would make k and a be a negative? Well, if you have a square root and under the root here, if these are opposite signs, so meaning if it was positive k divided by negative a, you have a problem. Or if it was negative k divided by positive a, you would have a problem. Well, what can you draw a conclusion by this right here? Well, you can say that if opposite signs, then, on the k and a, on k and a, then no zeros. So for example, it would be like if you had 2x plus 3 squared. Oh, sorry, actually, it'd be the same. Sorry, if same signs on k and a, then no zeros. And I'm going to add right here. In vertex form. And why did I correct myself? Because notice that when you set this to 0, so if I bring this a plus 3 over here, so notice how they're the same sign. So this is a positive, and this is like a positive here. But when you set this equal to 0, all right, it's this value right here, when you bring it over to the other side, will become minus 3. But this one doesn't, okay? This one, you just simply divide the whole thing by 2 after, so you have it over 2. So in this scenario I have created right here, your root of k over a would be minus 3 over 2, and that would be a problem. Well, you will have 1 0, or there are two zeros, if it was the other scenario. Okay, so 2 zeros if k and a, now this one is in vertex form, have different signs, have opposite signs. And let's think about that. So if we do 0 equals, and let's make my a negative. So we'd have negative I'll do a different number, 4x plus 3, and now make this one opposite sign. So we have, in this case, if that was negative, that means this one would have to be a positive 4, or positive any number, 5. But now look what happens. When you bring this over, you would have minus 5 equals minus 4x, squared, plus 3 squared. And then you'd have to divide both sides by the negative 4 in front, which would cause this whole thing right here to become a positive. So it would end up being 5 over 4 taking the square root. So you have the correct answer, like you have a positive there. And then the last scenario is when you have one solution. And that happens when the k is equal to 0. So if you have something like 3x minus 2 squared, and then plus 0 on the backside here, I'll write it. Let me just give myself some more room. Because that 0 isn't even there, right? So it's actually not even there. Well, what happens when you want to isolate for x? Well, in this case, you would divide both sides by 3. Well, that gets rid of this 3 here, but 0 divided by 3 is still 0. So then it's x minus 2 squared. And then take the square root, that's your next step. What is 0 squared? Still 0. So now you have x minus 2. So then bring the 2 over, and it's just x is equal to 2. So if k is equal to 0, there's only one solution. Or I shouldn't say, I'm using the word 0, so 1 is 0. Okay? So same signs, opposite signs, or if k is 0. Those are the 3 ways you can figure out how many zeros or solutions there will be in a quadratic. Okay, example 3. Given the following parabola, determine the values of a, h, and k, state the mapping rule, state the coordinates of the vertex, state the direction of opening, the equation of the axisymmetry, the y-intercept, and use the mapping rule to fill in the table of values for the transformed parabola, and graph it. So, a value, minus 2. K value, or h value, 3. Your k value, 2. So mapping rule, x plus 3, comma, and then you'd have negative 2. Oh, why am I writing in black? Minus 2, y plus 2. There's your mapping rule. Your vertex is at the coordinates at h and k, so 3, 2. The direction of opening, well, in this case, our a has a negative value. So if the a is negative, that means we're going down. Your axis of symmetry, well, the axis of symmetry is at your h value, but it's x equals h, so x equals 3. And then your y-intercept is when the x value is 0. So substitute 0. So y equals minus 2. And then you have your x minus 3. So 0 in this case, because we're solving for when x is 0, minus 3. Square that, plus 2. So you get y equals minus 2 minus 3 squared, so 9, plus 2. And then y equals negative 2 times 9 is negative 18. Plus 2 to that, that's y equals minus 16. And the y-intercept, please put it in a coordinate, would be at 0, minus 16, okay? Okay. So we've filled in the chart. Now, the last one is part 6, is saying use the mapping rule to fill in the table of values. So again, you start with your parent, right? So we're taking all of these x values and substituting them in there. So if you substitute minus 2, you will get 4. 1 negative 1 gives you 1. 0. 1, 4. So now you're taking all your x's, you're adding your 3 to them, and you're taking all your y's, you're multiplying it by -2, and adding 2. And again, this should be a review. So if you substitute your first one, all right, if we substitute this -2 for that x there, that becomes 1. Put in the 4, that's -8 plus 2, so this is -2. You're substituting in the 4 plus the 2, so it's -8 plus 2 minus 6. I'll just show you the next one, but -1 plus 3, because you're doing this -x next. -1, sorry. So 2. And then -2, 1 plus 2 is 0. And you just keep that pattern going. So this would be 3. This would be 2. This would be 4. This would be -2, 0. Oh, sorry, did I make a mistake? No, it says, yeah, 2. And that one I did it correctly, yeah, -2 here. Okay, 2 and 5. And then this one would be -8 plus 6 is -6. Perfect. And again, what did you just find? You found your transformed ordered pairs. So 1 minus 6, 2 and 0, 3 and 2, 4 and 0, 5 and -6. So let's graph those purple points right there. So we're going to graph 1 and -6. So 1 and -6 is right down here. We have 2 and 0. So 2, 0. 3 and 2. 4 and 0. And 5 and -6. Right there. So connect your dots now. Arrows and label your graph. Y equals -2, x -3 squared plus 2. Okay, so that's it for today, and we'll work on those problems in class.